Hi guys, this is Arpana from Sri Venkateshwara College of Engineering of Electronics and Communication Engineering. Today I am here to explain the analyze modulation techniques in digital broadcasting. Introduction to digital TV broadcasting. Digital TV broadcasting has a revolutionized the way we receive the television signals. It offers the improved picture and also the sound quality when compared to the analog broadcasting. Understanding these modulation techniques it is one of the essential for optimizing the transmission efficiency. Importance of modulation. Modulation it is the one of the process of varying a carrier signal in order to transmit the information. So as we can observe in this image, there is a message signal, carrier signal, and amplitude modulated signal, where it is the waveforms of the amplitude modulation. And also it will be enabling the efficient transmission of data over the various media. Effective modulation techniques they can enhance the signal robustness and minimize the interference. Types of modulation techniques. So there are several modulation techniques which will be used in the digital TV broadcasting. Each technique it will be having a unique characteristics that will suits the different transmission conditions. Common types it may include QAM, OFDM and PSK. So modulation it is having a two types. One is the analog modulation, the other one is a digital modulation. When we come across the analog modulation, it is having three types as well as a digital modulation, it is also having three types. Whereas analog modulation like amplitude modulation, frequency modulation, phase modulation, and digital modulation means it is amplitude shift keying, frequency shift keying, phase shift keying. QAM, quadrature amplitude modulation. So quadrature amplitude modulation, it will be combining both the amplitude as well as a phase modulation in order to transmit the data. It will be also allowing for the transmission of multiple bits per symbol, increasing the data rates. Higher order QAM, it may achieve the better spectral efficiency at the cost of robustness. So as we can observe in this image what we have explained in the sentence that they have shown in the image. So if there is a higher order QAM, so that it will be achieving a better spectral efficiency. OFDM, that is orthogonal frequency division multiplexing. So it is a one of the multi-carrier modulation technique that will be dividing the signal into multi-sub signals. So as we can observe in this image, it is also highly resistant to multipath interference and it is also used in the DVB-T and DVB-T2. OFDM it can effectively utilize the bandwidth which will be making it ideal for the high data rate applications. So wireless transmissions are compared. That means how orthogonal frequency division multiplexing and standard frequency division multiplexing as well as the single channel wireless transmissions are compared. So as we can observe the waveforms of these where QFDM, the subchannels, whatever that, they are overlapped. But FDM, there is no overlap of the subchannels. Single channel, only one or band users are available with the bandwidth. Phase shift keying, that is PSK. So it is also one of the modulation technique that will be encoding the data by varying the phase of the carrier wave. And also it is a robust against a noise and is commonly used in satellite as well as the terrestrial broadcasting. Variations of PSK such as it may be QPSK also, and it can transmit the multiple bits per symbol. As we can observe in this image, there is a wavelength like for example like if there is a 1 and if it is changing from 1 to 0, even there is a change from change in the waves also. Whereas in the waveform the amplitude from 1 to 0 it is continuously changes. If there is a continuation 0, then the waveform will be in a sine wave. If it is varies from 0 to 1, then it will be again changes. So like this, the frequency shift keying takes place. Comparison of the QAM and OFDM. While QAM is effective for point-to-point communication, but the OFDM it will be excels in the multipath environments. QAM is having a higher data rates, but it is also more susceptible to noise and as well as the interference. OFDM's resilience makes it suitable for the urban broadcasting scenarios. Error correction techniques. Error correction is vital in digital TV broadcasting in order to maintain the signal integrity. Techniques such as Reed Solomon and turbo codes, which are commonly used for the error correction. And these methods they may help in order to recover the lost data and also to improve overall transmission reliability. Channel allocation and the bandwidth. So efficient channel allocation which is one of the crucial for maximizing the use of the available bandwidth. Modulation techniques they must be adapted based on the allocated frequency spectrum, and proper bandwidth management it may ensure the minimal interference and also the optimal signal quality. Impact of the signal interference. So interference it can significantly degrade the quality of the TV broadcast, whereas the modulation techniques are designed in order to mitigate the effects of the various types of the interference. Robust techniques they can maintain the signal integrity even in the challenging environments also. Adapting to transmission conditions. So digital TV broadcasting it may require adaptive modulations because there will be various conditions. For that various conditions we need to respond. So it should adapt the that means it should require the adaptive modulations and techniques like adaptive modulation and also coding which may call as AMC. It can also optimize the performance in the real time. This adaptability it ensures the quality of the viewing experiences regardless of the signal fluctuations. So as we can observe in this image, there is a amplitude modulation where here in amplitude modulation the input will be modulating wave, and in all modulations the input will be modulating wave only. Where sine in frequency modulation amplitude modulation we will be taking the sine wave, but in digital modulation we will be taking the square form and carrier wave. After both the modulations we will be getting the modulated results. And for amplitude modulation, there is one of the modulated result. Frequency means the variation of the frequency takes place. Future trends in modulation techniques. The evaluation of digital broadcasting it is leading to a new modulation innovations. Techniques such as the 256 QAM and advanced OFDM variations are being explored, and also there is a 16 QAM also. Future trends it may involve the integration with the 5G technologies for the enhanced broadcastings. Case study DVB-T2. So DVB-T2 it will be employing the advanced modulation techniques for the terrestrial broadcasting, and also it will be using the 256 QAM as well as the OFDM in order to achieve the high data rates as well as the improved coverage. So this technology it will be supporting the multiple services and also enhances the viewers experience. Global standards in digital TV broadcasting. So various countries they have been adapted for the different standards for the digital TV broadcasting. Like standards like ATSC, DVB, and ISDB. They will be defining the modulation techniques which they are used. And understanding these standards, it is one of the essential for the compatibility and also interoperability. So worldwide digital TV standards like DVB-T, DVB-T2, ISDB-T, CTTB, which we will generally which is from the China, and from Korea like TDMB and ATSC, and the last is ATSC and ATSC MH. modulation and the reception equipment. The success of the modulation techniques, they will be mainly relying on the compatible reception equipment. Step set-top boxes and integrated tuners, they must effectively decode the modulated signals. So advances in the technology, they will be continue in order to enhance the performance of those devices also. Role of the satellite broadcasting. So satellite broadcasting, it will be you mainly using a unique modulation techniques. Why means because in order to because due to its transmission environment and techniques, like there are so many techniques which are worldwide across, like a DVB-S2, they will be utilizing the QPSK and 8PSK for the efficient bandwidth use. And satellite broadcasting, it will be providing a coverage to remote as well as the rural areas effectively. The role of regulatory bodies. So regulatory bodies, they will be setting a one of the standards for the modulation techniques in the broadcasting, and they ensure the compliance with the technical specification. Later they will be preventing the interference. Their role, which is a crucial in maintaining the fair and the efficient broadcasting practices. So there that too, it should be set up by the government. They should be monitored, guided and controlled. Later on, particular sectors like banking, insurance, healthcare, etc. The role of regulatory bodies will be taking place. Challenges in the digital broadcasting. So, despite advancements and also future techniques, trendings, digital broadcasting, it will be facing a several challenges, issues such as signal degradation, interference, equipment compatibility, pursuit, and so on. Ongoing research aims in order to overcome all these obstacles and also enhance the broadcasting quality. Conclusion. Modulation techniques are the fundamental in order to success of digital TV broadcasting. So continuous improvements and the adaptations, they are necessary in order to meet the evolving demands, and also the comprehensive understanding of these techniques, which are essential for industry professionals. Thank you.